So tonight we're going to talk about synthetic division, and synthetic division, as its name implies, is something that's sort of made up, but it's a made up shortcut for dividing polynomials. And like most synthetic things, it does have some limitations. Synthetic division is basically a shorthand method for dividing polynomials. Its requirements are that the divisor has to be a linear binomial. So it has to have a coefficient of 1. So we're talking about things in the form of like x plus 3 or x minus 4. In order for synthetic division to work, the polynomial must be written in standard form. Now this is not different from the previous night's work, using zeros as a coefficient for any missing terms. That's our placeholders. And the divisor must be in the form, as I said, x minus r or x minus a. Depending on the textbook, you may see it different ways. So let's go ahead and start with an example so you can see the process. So first things first, we have this as our dividend and this is our divisor. Our divisor meets the requirements of being in a linear form, degree 1, and having a coefficient of the x term 1. Now we look at our dividend, we have to make sure that we put our dividend in standard form. So we're going to put the highest degree term first. So we have our 2x cubed minus 7x squared minus 8x plus 16 divided by x minus 4. Along the side here I have all the steps written for using synthetic division, but I'll go through them and talk about them as I go. So the first step when you're using synthetic division is to write the coefficients, just the coefficients of the dividend in a row. Okay, so we have a 2, a negative 7, don't forget to include the sign, a negative 8, and a 16. Now, if there were missing terms, so if it didn't go x to the third, x squared, x, and then x to the 0, or the constant, I would add a 0 in as a placeholder. Next, we take the value of, and this one says a, so I'll adjust this to make that an a, but it depends on the textbook. Sometimes it's x minus r. Okay, so we're going to take the value of a for the divisor in the front, so that would be, in this case, just the 4. And we put the 4 into a little box like this. Okay, then we're going to draw a T, and we're going to leave some space underneath each of those. Okay, and that's our sort of T shape. Okay, and then we're going to bring the first coefficient down below the T. Then we're going to take this coefficient, we're going to multiply it by 4, and we're going to put that answer here. So I have 4 times 2, which is 8. It's similar to the process of long division, but without actually having to go through the process of long division. Same idea here. Next, we're going to go ahead and combine these two coefficients. So just watch your signs. I have an 8 and a negative 7, which gives me a positive 1. And then I repeat the process. So now I'm going to take this 4, multiply it by 1, and put the answer here. Then combine. So a negative 8, a positive 4 gives me a negative 4. And then repeat one last time. So I have 4 times negative 4, answer goes here, negative 16. Combine. 16 plus negative 16 gives me an answer of 0. This box here will always contain the remainder. Now that doesn't matter for us yet, but eventually we will have polynomials that are divided and there's a leftover, meaning it doesn't divide evenly or that the divisor is not a factor of the dividend. Okay, so I'm going to ask you to go ahead and try to do example 2 once you stop the video, I do want to remind you that you're going to need some placeholders here because we have an x cubed term and a constant. Okay, so I'll see you all tomorrow. Have a great day.